13 billion years ago, everything that exists was squeezed into a point smaller than the head of a pin. Then the biggest explosion of all time happened, the Big Bang. But here's something that will blow your mind. The universe didn't explode inside somewhere. It created space itself while it grew. Imagine inflating a balloon, but there's no air outside, there's no room, there's nothing. The balloon is creating reality itself while it grows. Scientists discovered that the universe is still doing this right now, creating more space every second, expanding into nowhere because there is no outside. How can something grow when there's nowhere to grow into? Subscribe to the channel, leave your like and comment from what part of the world you're watching, because now I'm going to tell you everything. What is the universe? Can you imagine everything that exists all at once? This question helps us start to think about something very big and very important. The universe is not just a place. The universe is every single thing that exists. It is every star in the sky, every planet you can think of, and every small piece of dust. It is also every bit of light, every drop of energy, and even all the space between everything. Every second that has ever passed is part of the universe too. The universe is all that there is. There is nothing outside it. There is no empty area around it, and there is no wall that holds it in. When you look up at the sky at night, you see stars and darkness. You might see bright spots that are planets, or even very far away galaxies. All of these things are inside the universe. But the universe is also the blackness between the stars, because that blackness is space. Space is not empty. It is a part of the universe. The space between you and your friend, the space between planets, and the space in the farthest reaches of the sky are all part of the universe. Now, scientists say something about the universe that sounds strange at first. They say the universe is expanding. What does this mean? Expanding means getting bigger. But what is getting bigger? If the universe is everything, how can it become bigger? It cannot grow into another place or into another space because there is nothing outside it. Sometimes we think of things growing by moving into more room. A ball gets bigger when you blow air into it, and it grows into the air of a room. A city grows when it fills more land. But the universe is not like these things. The universe is all the land, all the air, and everything that exists. There is nothing outside it for it to move into. So when scientists talk about the universe expanding, they mean something different. They mean that the space inside the universe is getting bigger. The things in the universe, the stars, galaxies, and everything else are moving farther and farther apart from each other. The amount of space between every object is slowly growing. Imagine 2 points in space, one where you are and one far away, maybe where a star is. The distance between you and that star grows over time, not because you are moving and not because the star is moving away in the regular way, but because the space between you and the star is growing larger. It is as if space itself is stretching. Every part of space keeps stretching, making all points farther and farther apart from each other. But you might want to ask, if space is growing, what is it growing into? The answer is that it is not growing into anything. There is no border, no edge, and no outside. When the universe expands, it does not push into a new kind of space. It makes more space inside itself. The idea of outside does not make sense here because nothing exists outside the universe, not even empty space. If you traveled in a straight line, never stopping, you would never reach a wall or an edge. You would never find a place where the universe ends or a place where it meets nothing at all. No matter how far you could travel, you would stay inside the universe. Space itself continues everywhere. This is very different from most things we know. Our normal lives are full of edges and borders. We live in a house and there are walls around us. We walk in a park and the park has fences or streets around it. Even the planet we live on has a surface, and outside our planet there is space. But the universe is not like any of these things. There is nothing outside it, and it does not have an edge. It means that when we ask, where does the universe end? Or what is after the universe? We are asking the wrong kind of question. There is no after, there is no edge. The universe is all there is, and everything happens inside it. When scientists say that the universe is expanding, they are very careful with their words. They do not mean that the universe is exploding like a firework or that it is growing like a balloon with more air. There is no outside that the universe can move into. There is just more space inside. Sometimes people get confused and imagine the universe growing inside something bigger like a balloon in a room. But this is not what scientists mean. The universe is not inside anything else. The universe is not a ball in a box. The universe is not growing to fill a void because there is no void to fill outside it. This idea can feel strange and even confusing because there is nothing else in our lives that works in this way. We are used to things being inside something, and we are used to edges and outsides. But the universe itself does not have an outside. The expansion of the universe means more distance is appearing between things inside it. If you could mark two faraway galaxies and wait a very long time, they would both be farther apart than before. The space between them would have stretched and grown. Scientists see this by looking at the light from galaxies in space. When they look at these galaxies, they see that the light coming from them is stretched or shifted toward the red part of the rainbow. This is called redshift. The farther away a galaxy is, the bigger the redshift that scientists see. This tells scientists that the galaxies are moving away from us, and it is happening in every direction. But it is not just that those galaxies are moving away on their own. What is really happening is that the space between us and the galaxies is growing. The light has to cross more and more space as time goes on, and the space itself is getting stretched. Every part of space is part of this change. That is why all galaxies get farther away from each other as the universe expands. So, the universe is everything, and expansion means all the space inside it is growing. That change is not like growing inside a bigger place, but like space itself having more of itself everywhere. If you ask, how do I know where the edge of the universe is? The answer is that there is no edge. If you ask, can I go outside the universe? The answer is that you cannot, because there is no outside. If you ask, what is on the other side of the universe? There is nothing on the other side. Every direction leads you deeper into more universe and more space. The universe does not sit inside anything else. It does not need more room to grow because it creates more space inside itself as it expands. But you might still wonder, how can something have no edge? The best way to understand this is to remember that the universe includes everything, all matter, all energy, all of space, and all of time. When scientists talk about the universe, they mean all of reality. If you try to imagine leaving the universe, there is nowhere to go because space and time only exist inside the universe. This is very different from how we see most things in life. Usually, if you walk and walk, you will run into a wall, a door, or some kind of limit. But the universe is not a normal thing. There is no edge that you can reach. You cannot run out of space. You will not find a place where the universe stops and nothing begins. There is no line between the universe and something else. The universe is all of space itself. Maybe you have heard the word infinite when people talk about space. Some people say the universe is infinite, meaning it goes on forever. Others say the universe is very, very big, but not actually infinite. Either way, there is no edge or border. You cannot reach the end. If you could travel forever, you would just keep seeing more universe. So, the universe is all that is real, and it stretches in every direction. The expansion means that this all is getting larger everywhere, inside itself, not by moving into something outside, but by making more space as time moves forward. The universe is also all of time. This means every past moment, every second happening right now, and every future second that will ever happen. There is no time outside the universe either. When you think about time running forward, all of that change happens inside the universe. When you picture space between two stars, that space is real and part of the universe. When you imagine a dark part of the sky with nothing in it, that part is not outside the universe, it is space, and space is a part of everything. Every atom, every beam of light, everything you can see or touch, and all the invisible parts we cannot see, these are all parts of the universe. There is not a thing or a place that is not part of the universe. So, to understand what scientists mean when they say, the universe is expanding, remember, they do not mean it is stretching into anything or pushing against something. It means that the space where everything is itself getting bigger. This changes the distance between every object and every group of objects everywhere. It does not matter if you are in one galaxy or another, or if you are at one edge or another. Every place inside the universe sees the same thing happen. Everywhere, space is growing. Every part of the universe gets farther from every other part as time goes on. Because there is no outside, there is no need for the universe to move into something new. All the growth happens right inside as the space itself stretches. It is not that galaxies are being flung away like rocks in an explosion. It is that the space between them, and all space in every direction, increases all the time. This idea is supported by the way scientists see galaxies and measure light. When we study the universe, we see that it makes more space between things, not that it fills a bigger box. The universe is not growing into a room, a shell, or a giant area outside itself. It is simply all that exists, getting more space everywhere inside itself. To sum up, the universe means everything, all space, all time, all stuff. Expansion means the space inside the universe is growing, making everything move farther apart. Nothing is outside the universe. There is no border, edge, or limit to reach. The universe expands by growing more space inside, not into anything else, but by having more space in every direction as time passes. Every time scientists look at space, they see the same thing. All the objects inside get farther apart, but the universe never has to push into something new because there is nothing else to push into. This is what it means to say the universe is all that there is, and that expansion is the making of new space inside everything. When you think about all the space inside the universe growing, you might start to ask an important question. How did it all begin? At the deepest level, where did the universe come from? To answer this, scientists study the earliest moments of everything, the time before there were stars, planets, or even space as we know it. Everything we see around us started in a very special way, and to understand why the universe is expanding, we have to talk about its beginning. A long, long time ago, so long that it is almost impossible to imagine, there was no space and no time at all. There was not even darkness because there was no place for anything to exist. There were no objects, no air, no light, and no matter. The universe simply did not exist yet. This is hard to picture because everyone is used to having something rather than nothing. But the nothing before the universe was not empty space. It was the absence of all space and time. Then something happened. Scientists call this event the Big Bang. The Big Bang was not an explosion in the middle of empty space. It was the moment when the universe itself began. Space and time both started at that very first moment. Before the Big Bang, there was no before, because time did not exist yet. There was also no outside, because there was no space to be outside of. At the very beginning, the whole universe was packed into a single, incredibly tiny point. This point was not just small, it was so dense and so hot that no one can really understand how extreme it was. All the matter, all the energy, and all the space that would ever be in the universe was crushed into that point. Everything that is now spread out in galaxies, stars, and planets was once squeezed together. In the instant the Big Bang happened, space itself began stretching out. Time began to move forward for the first time. There was no place for the new universe to grow into because there was nothing outside it. Instead, the universe began to make its own space as it grew. Every direction opened up at once. Everything that would ever exist had its beginning right there. During the first moments, the universe changed extremely quickly. In a tiny fraction of a second, the universe became much, much bigger than that first tiny point. This process is called cosmic inflation. It means that the universe increased in size by an enormous amount nearly right away. But this still does not mean it pushed into empty space. The space was being made along with everything else. When the universe was still incredibly new, it was unimaginably hot. Temperatures were so high that normal matter, like atoms and particles, could not even form yet. There was only energy flashing back and forth. As the universe expanded, it started to cool down. After only a short time, the first basic pieces of matter, called particles, began to form. At this early time, everything was still packed very close together. There were no stars, no planets, and no galaxies. Everywhere was the same, full of hot energy, getting just a little bit cooler every moment as space expanded. Over time, small changes started to appear in this thick soup of energy and particles. These changes would later become the galaxies and stars. After a few moments, the universe cooled enough for the first protons and neutrons, the building blocks of atoms, to appear. These building blocks started to team up and make simple elements like hydrogen and helium. Soon, the universe was full of tiny atoms floating in space. Still, there was no light shining as we know it, because atoms and energy were still too mixed up, and the universe was still too hot for light to travel far. Hundreds of thousands of years passed. The universe kept getting bigger, and as it grew, it also kept cooling down. One important thing happened after about 380,000 years. For the first time, atoms could finally hold onto their electrons because the universe was cool enough. When this happened, light could finally travel freely through space. Scientists call this the moment when the universe became transparent. Before this moment, light was always getting blocked or bounced around, but from now on, light could move smoothly across great distances. Even today, scientists can catch some of this ancient light. This is called the cosmic microwave background. It comes from every direction in the sky. No matter where scientists look, they can see the leftover glow from when the universe was just starting to let light travel freely. This old light is a very important clue about the beginning of everything because it carries the marks of what happened back then. At the start, the universe was all in a very simple shape, just a hot, thick soup of atoms and energy. Little by little, tiny spots became just a little bit denser than others. These small differences were the seeds of everything we see today. Where there was just a bit more matter, gravity pulled more and more atoms together until, much later, stars started to shine and galaxies began to form. Why is it called the Big Bang? The name makes it sound like an explosion, but it was not an ordinary bang. It was not the kind that happens when something blows apart in a room. It was the creation of space and time itself, starting everywhere at once. Scientists needed a simple way to talk about the beginning, so they used the words Big Bang. But what really happened is very different from things we experience every day. Scientists study these early moments by looking at all the clues the universe has left behind. They use special telescopes to see the light from the farthest objects. They measure the tiny differences in the cosmic microwave background. All the evidence tells the same story. There was a time when there was nothing, and then there was a time when space, time, and energy all began together. The Big Bang is not just a theory. It is supported by much evidence. When scientists look far into space, they are also looking far back in time because it takes so long for light to travel. The farther away something is, the older the light is when it arrives here. This is how scientists can see what the young universe looked like. Every time they find something new, it matches the idea of the universe starting small, hot, and dense, then growing bigger and colder over time. So, the beginning of the universe was the beginning of everything: space, time, matter, and even the rules that control how everything works. If you ask what was before the Big Bang, the answer is that there was no before. Time itself started with the Big Bang. Asking what was before is like asking what is north of the North Pole. The question does not have an answer because time itself did not exist until this moment. Some people wonder how something can start from nothing. Scientists still discuss this question, but one thing is clear from all the evidence. The universe had a definite beginning. The details of how this happened and why it happened are still being studied. But what comes after, the history of how the universe grows and changes, can be learned by looking at the things around us and the signs left from the early universe. What happens as the universe goes forward in time is shaped by what happened at the beginning. The universe does not expand into another space, and there is no outside or border. The space itself started at the Big Bang and has kept getting bigger ever since. This means that all the distance between everything in the universe began very close together, and only later, as space grew, did objects get far apart and spread out into the universe we see today. There are many reasons scientists are sure about this beginning. First, the distant light we see from very old galaxies shows us that they are moving away from us, as if space between us is getting bigger. This matches what we would expect if space is expanding. Second, the cosmic microwave background is real proof of the first light that ever traveled freely. Third, every time scientists check for other clues, like how much of the lightest atoms exist, they match what the Big Bang theory says should happen. The story of the universe is a story of change. It started as something unbelievably tiny, hot, and full of energy. Then it became what we now see as a huge universe full of galaxies, stars, planets, and empty space. But all of this started from a single beginning. Even though there are still mysteries about the first moment, the fact that the universe has a starting point means there is a single history shared by everything. There are no places outside where something different can happen. Every object, every bit of energy, and every part of space inside the universe comes from that first moment. As the universe continued to stretch and space grew, more and more of the places we now see in the night sky appeared. Billions of years would need to pass before stars could light up and galaxies could fill the sky. But the beginning set the rules for everything: the way space expands, the way light travels, and the way objects move apart. Gravity is one of these important rules. Even when the universe was just beginning to form atoms, gravity started to shape the future. It slowly pulled more matter together where there was just a bit more than average. These places eventually became the stars and galaxies. This change from a uniform, hot universe to a universe with things is very important. Every star, planet, and person today can trace its history back to the changes that happened in those first moments. There was no outside force pushing the universe, and there was no empty area the universe grew into. Space and time just began to exist and then to expand, carrying everything inside with them. The more scientists look at space, the more they learn how the beginning connects to what we see today. By looking at galaxies far away, they can see how spread out everything has become since those early days. By studying the cosmic microwave background, they learn about the tiny differences in the early universe and see how those small changes made the universe less smooth and empty. All of this tells us that there is no place outside the universe from where the Big Bang happened. The universe did not happen in one corner or place. Every part of the universe started at that moment. Space grew everywhere. It did not expand from a point in space, but made new space at every point. Every direction, every corner, and every location began at the same time. Even now, when scientists use powerful telescopes to look back to the earliest galaxies, they see proof of the universe expanding and spreading apart. They do not see any border, and they do not find a place where the universe started from and pushed outwards. It was the creation of all space and time together, not the pushing of matter into empty space. This is why the universe today is still expanding. The process that started with the Big Bang continues. The distances between objects inside the universe keep growing. The beginning did not just make space and time, it started them in such a way that they could keep growing and changing. The story of the universe starts with the birth of everything, not with something moving into a new area. There is not, and never was, an edge or a place the universe could reach and stop. It always has been all there is. The time since the universe began is very long. Scientists have measured the age of the universe and found it to be about 13.8 billion years. This number is very large, and it helps us see how much time has passed since everything began as a very hot, tiny point. All the changes and events in the universe have happened during this time. As you think about the universe and where it came from, it is important to remember that all objects, all energy, all time, and all space came from the same starting point. The entire history of the universe is a story of growing, changing, and expanding from that first moment. All the galaxies, including the one we live in and all the others we can see, come from the same beginning. No matter where you are in the universe, the story is the same. There is no special place that is different from the rest. The universe does not expand into another space, and there is no higher or lower point. From the first moment, everything has been inside the universe, and all of space has grown together. Light that travels from the farthest galaxies takes billions of years to reach us because those galaxies are so far away. Every bit of light we see brings us a message from the past, from when the universe was younger and smaller. This is how scientists know what the early universe was like and how the space between galaxies has spread out over time. Over the long life of the universe, the changes that started with the Big Bang have shaped everything. The universe went from a single, incredibly hot and dense point to a wide, expanding space full of matter, energy, and light. There was never a time when it was pushed from outside, or a time when it reached a wall or border. All of expansion and all of change happen inside the universe itself. This is why the idea of the Big Bang is so important for understanding why the universe is the way it is today. The creation of space and time, the forming of the first atoms, the release of the first light, all these things are connected to the story of expansion. Each event comes from the one before, leading to the world, the stars, and the sky we see tonight. When you look into the sky, you are seeing the results of something that started from a single, powerful beginning. The story of the universe is the story of everything growing from that very first moment, with no edge and no outside. Every part of space, every moment of time, and every object you can see or measure came from that starting point. And the changes that began then are still happening today. The universe has been getting bigger and bigger ever since it began. Every part of space has been stretching out, and the results of this stretching can be seen today. For a very long time, all the matter and energy in the universe was spread out closely, like a thick fog. As the universe expanded, this fog became thinner and space between objects became greater. Galaxies began to form, and stars started to shine in many different parts of the universe. The space between galaxies is not fixed or stuck. Instead, it grows as time goes on. This means that the places where you find one group of galaxies and the places where you find another group of galaxies are slowly moving farther apart. The stretching out of space is happening everywhere at once. There is no special center for this stretching. No matter where you are, you would see space growing in every direction. The growing of space is not the same as moving through space. When a car drives down a road, it gets farther from one place and closer to another place. But when space itself grows, everything inside it moves apart, even if nothing is moving on its own. It is the space itself that gets larger. The stretching of space mostly affects large distances between groups of galaxies. Inside a galaxy, the forces holding stars together are very strong. Gravity pulls stars and planets close. The effect of the stretching is so small at these small scales that it does not pull things apart inside galaxies or solar systems, or even inside atoms. The expansion changes the very big distances, the space between groups of galaxies, not inside them. People sometimes wonder if the Earth will get farther away from the Sun because of the expanding universe. The answer is no. The force of gravity that keeps the Earth close to the Sun is much stronger than the gentle stretching of the universe on small scales. The same is true for the atoms that make up everything you see. The forces inside them are very strong, and the expansion of space does not make them come apart. The growing of space starts to be important only when you look at places much bigger than a galaxy. Inside a single galaxy, like our own, gravity holds stars in a big group. Planets travel around stars, and the stars travel around the center of the galaxy. This movement and these patterns are not changed by the stretching of space. Even though the whole universe is growing, galaxies and solar systems do not drift apart. They stay together because the forces inside them are much more powerful than the slow stretching of space. The stretching of space happens everywhere, but it takes a very, very long time to make a difference. Over billions of years, the distances between the groups of galaxies have become much larger. But inside a galaxy, things stay close together through all that time. Gravity is the key to understanding why stars and planets do not move away from each other. Every galaxy is like an island held together by gravity. The expansion of space is something we only notice when we study objects that are very, very far away from each other. Scientists look at the light from these faraway places to know the history of the universe. When they measure the light, they can see that the space between groups of galaxies is growing. They do not see galaxies flying apart inside themselves. The shape and size of galaxies remain the same because the force of gravity inside is much greater than the force of expansion. This growing of space does not put pressure on things. It does not squeeze or pull objects apart if the force inside them is greater. If you could zoom in on your body, you would see that atoms inside you are not drifting away from each other because of the expansion. The atoms are held together too tightly. The same is true for the solar system and the stars inside a galaxy. When we look at the wider universe, we see that galaxies are arranged in groups called clusters. Each cluster has many galaxies pulled together by gravity. These clusters can have hundreds or even thousands of galaxies, each one containing billions of stars. Between the clusters is empty space, almost nothing at all. The stretching of space makes the clusters move apart from each other as time passes. The more time goes by, the more these clusters separate, and the bigger the universe becomes. The reason why the expansion does not break clusters apart is the same as for galaxies. The gravity inside a cluster of galaxies is still strong enough to hold them together, even as space stretches. The space between different clusters grows, but within a cluster, gravity fights against the stretching. Far away from any cluster, in the biggest empty areas of space, the stretching happens freely. There are no strong forces holding things together, so the space simply grows larger and larger. Over billions of years, these empty places get even emptier as the groups of galaxies move ever farther apart. This is one of the reasons why we can say the universe has no edge or center. No matter where you look, the same stretching is happening. Every galaxy sees the others moving away, not because one group is special, but because the space itself is getting bigger everywhere. The universe's expansion is something that scientists can measure. They can watch distant galaxies and see how the space between them is changing over time. By using telescopes and measuring the light from these galaxies, it is possible to see that the farther away a galaxy is, the faster it seems to be moving away from us. This is not because the galaxy itself is moving quickly where it is, but because the space between us and the galaxy is growing. The light from a faraway galaxy travels for billions of years to reach us, and during all that time, the space through which the light travels also grows. Every part of space keeps getting bigger, and this changes the distances everywhere. There is not a single part of the universe that stands still while other parts grow. Everything is part of this change, and it happens to all of space at once. When scientists try to picture the growing universe, they need to remember that there is no outside and there is no edge. There is nothing for the universe to move into. Instead, each point in space has more space appearing around it, making all points move apart. Galaxies do not get larger, they do not stretch apart or break. It is only the space between the big groups that grows. When we say the universe is expanding, it means the very fabric of space is changing. This fabric grows in every direction. Imagine if you could mark the spots of several galaxies very far from each other. As time goes on, you would find every spot is farther from every other spot. But if you look inside a galaxy, the stars do not drift away from each other. The space inside stays the same size. If you could look at the universe as a whole, you would see there is more empty space now between galaxies than there was in the past. Scientists know this because they look at galaxies that are very, very far away, which means they are also looking very far back in time. The light from these galaxies started traveling toward us billions of years ago. When scientists measure the distance between these ancient galaxies, and then compare with galaxies closer to us, they can see that the farther away galaxies are moving apart faster. This process of measuring how the universe grows is not simple, but all the results agree. The space between groups of galaxies gets bigger, while the galaxies themselves stay together. No place is special. All space everywhere is taking part in the expansion, and there is no center from which everything started moving. Galaxies can move around on their own, pulled by the gravity of nearby clusters, but the big picture is that the whole universe is stretching out over time. This stretching affects only the biggest distances, not the little ones where gravity and other forces are at work. Another important point is that as space stretches, it does not add new material or create more stars or galaxies just by stretching. The matter that exists is just spread farther apart. Galaxies become more distant from each other, and the empty spaces become greater. Sometimes people wonder if the stretching of space means there is new space coming from somewhere, or that something is being added. Scientists know that new space is not taking in material from outside because there is no outside. The space inside the universe simply grows, and every part takes part in this growth. There is no edge, no border, and no empty place around the universe. The process comes from within the universe itself. This means that over time, galaxies that we can see will keep moving farther away. Some will reach a distance where even their light cannot reach us anymore because space stretches so quickly that the light never gets here. This is another effect of space itself getting bigger, and it means that very distant galaxies will fade from view after enough time passes. As space grows, it becomes harder to see the most distant galaxies. Long ago, more galaxies were visible because their light had time to reach us. As the universe continues to grow, those galaxies move farther away, and the space between us and them gets so big that the light they send will never arrive. The rules that cause expansion happen everywhere the same way. The main force that keeps galaxies or clusters together is gravity. As long as gravity is stronger than the gentle push of the expanding space, the group stays together. When two groups are far enough apart, the stretching of space can pull them away from each other faster than gravity can pull them together. There is a limit to how much gravity can keep things together. Once objects are far enough apart, the expansion of space wins, and these objects get even farther apart as time goes on. This is why you see big clusters of galaxies move away from each other, not because of their own motion through space, but because space itself is changing. Scientists have made maps of the universe, showing clusters, superclusters, and the vast empty places in between. The maps look like a web, with groups of galaxies connected by thin lines and huge spaces where there are almost no galaxies at all. These empty places are called voids. In the spaces between voids, the stretching of space happens quickly, while inside clusters, gravity keeps things together. All of these facts help explain why the universe today looks the way it does. The clusters of galaxies stay close as a group, and individual galaxies inside a cluster stay close because of gravity. But the space between these groups grows over billions of years, making the universe as a whole grow bigger all the time. The universe has no end, no edge, and no place outside. It is made of space itself stretching, and everything inside simply gets farther apart. Every person, planet, star, and galaxy you see is a part of this history. The matter that makes up everything started out very close together when the universe began. Over billions of years, as the universe grew, everything spread out. Still, the groups and clusters you see are held by gravity, and only the very big areas between them are stretched by the expansion. The idea that space itself grows explains why the universe is not getting thinner in the places where things already exist. The space between galaxies grows, and the galaxies keep their shape because forces inside them are strong. The stars do not drift apart, and planets do not leave their place around stars. But the whole universe as a single thing grows bigger and older all the time. When you think of where you are right now, remember you are part of a bigger group called a galaxy, and your galaxy is part of a giant cluster. That cluster is moving farther away from other clusters, and the space between all these groups is growing every moment. This is how the universe changes without needing an outside, an edge, or a special place for growth to happen. The growing universe connects everything. There is no place that does not take part. The expansion started long ago with the beginning of time and space and has kept going, making the distances between groups of galaxies ever larger. This change is measured by the way light travels through space and by the way galaxies appear to move away from each other as the universe gets older. Every bit of new space is part of the universe, and it comes from within, not from outside. No one can travel to the edge, because there is no edge. No one can watch the universe stretch from outside, because there is no outside. All that exists is inside, and the growth of space touches everything at the largest scales. The fact that space grows affects only the biggest distances and is not felt at smaller scales helps keep everything inside organized. It explains why your body does not stretch apart and why the solar system still works the same way even as the universe keeps getting bigger. Gravity and other forces hold these things together, while space grows around them. This simple but powerful process, space itself growing everywhere, shows how the universe can always be bigger, always be different from before, and always be without an edge or a border. Everything in the universe shares the same space, the same time, and the same history of growing from a hot, dense beginning to today's wide, expanding universe. When you look up at the sky, you see stars, but you are also looking into a space that is still growing. This growing space affects everything on the largest scale, and it changes what we can see far away. Scientists began to notice something special about galaxies and the light they give off, and this helped them discover that the universe is expanding. By studying galaxies, scientists found clues that changed the way people understand the entire universe. Long ago, people thought the sky was always the same. They believed that stars and galaxies had always been where they are, never changing. But scientists started to ask questions. They wondered if there were ways to measure movement in the universe, or see if anything was changing. They needed something to help them see very far, and to know if distant galaxies were moving. Light is a very important tool for scientists because it can travel from the farthest galaxies right to us. When you look at stars and galaxies, the light that reaches your eyes or a telescope took a very long time to travel that far. Some of the light comes from places so distant that it has been traveling for billions of years. This means that when we look at very faraway galaxies, we are looking into the past, seeing them as they were when the light first began its journey. A big discovery happened when scientists looked very closely at the light from galaxies. They used special instruments called telescopes and devices that can spread the light out into its different colors. When you look at light this way, you do not just see the colors. You also see marks or lines in the light, called spectral lines. These lines show which elements are in the stars or galaxies and can tell if something is moving. When scientists started measuring these lines from faraway galaxies, they noticed something surprising. The lines were not where they expected them to be. They saw that the lines were shifted towards the red end of the spectrum. This shift to red is called redshift. It is a sign that something is moving away from us. If something is moving away, the light it gives off is stretched out, making it look more red than it would if it was standing still. This discovery was very important. Scientist Edwin Hubble and others measured hundreds of galaxies and found that almost all of them had their light shifted to red. This meant almost all galaxies in the sky were moving away from us. It was not just a few galaxies. It was almost every one they could measure, no matter which direction they looked. Even more surprising, the farther away a galaxy was, the more its light was shifted to red, and the faster it seemed to be moving away from us. If a galaxy was twice as far away, it was moving away almost twice as fast. This pattern was the same everywhere. It showed that the expansion was not just happening in one direction, but in all directions. Every galaxy, no matter where it was, seemed to be moving away from every other galaxy. This was the first direct evidence that the universe is expanding. Scientists realized that it was not just our galaxy moving, but space itself growing. The stretching of space made the distance between galaxies grow larger and made their light shift towards red. When you look at a faraway galaxy and see its redshift, you are seeing a message from the universe telling you that the space between us and that galaxy has grown since the light first started its journey. All of these discoveries were made possible by careful observation and measurement. Scientists needed to build special telescopes and use math to understand what the measurements meant. They could compare the speed of a galaxy moving away with how far it was from Earth. The numbers fit together in a way that could only be explained if space itself was getting bigger. Over time, scientists around the world confirmed that galaxies are moving apart from each other. The expansion was the same whether you looked in one direction or another. It was happening everywhere, and all galaxies were part of it. This supported the idea that the universe had a beginning, that it started in a smaller, hotter state and has been growing ever since. The redshift is not something you can see with your eyes, but telescopes and careful measurements make it clear. The light from galaxies is stretched as it travels through expanding space. The farther away the galaxy is, the more the space between us and the galaxy has grown, and the more its light is shifted to red. The effect can be small or very large, depending on how far away the galaxy is. The most distant galaxies show the biggest redshifts. Scientists also learned that the oldest light we can see, called the cosmic microwave background, is also stretched. This light comes from a time not long after the universe became transparent, when it was only about 380,000 years old. The expansion of space since that time has stretched this light so much that it is now seen as a dim glow in microwaves, not visible light. Everywhere scientists look, this glow is the same, another sign that the growing of the universe is happening everywhere. By looking at redshift, scientists can measure how fast the universe is expanding. They can use math to figure out how long the universe has been getting bigger. The numbers and patterns in the redshift show that the universe has been expanding for billions of years. These clues help scientists understand when the universe began and how it has changed over time. There is much more than just the speed and distance of galaxies to learn from redshift. By measuring the redshift of different objects, scientists can create a picture of how the universe looks at different times. They can look farther and farther away and see what galaxies looked like long ago. Some of the light reaching us is from galaxies as they were billions of years ago, much earlier in the universe's life. The redshift also helps scientists find new kinds of galaxies. Some galaxies are so faint and far away that we can only see them because they send special types of light. By looking for these faint, red-shifted lights, scientists discover new galaxies at the edge of what can be seen. These very distant galaxies help tell the story of how the first stars and galaxies formed and how the universe has changed from its early days. Each discovery using redshift adds to the picture of an expanding universe. There is no center to this expansion. Every observer, no matter which galaxy they are in, sees other galaxies moving away. The expansion happens everywhere at once, and it is not moving into anything outside. There is no edge, no border, no area where the expansion stops. Another way scientists use the light from galaxies is to study the way stars are born, grow, and die. By looking at different galaxies near and far, they see how galaxies change over time. Some have lots of young stars shining bright blue light, while others have mostly older stars that shine red. Scientists can even see galaxies merging together, pulled by the gravity of each other, forming new shapes. These events all happen as the universe gets bigger and the space between groups of galaxies keeps growing. By making careful maps of galaxies and their redshifts, scientists have learned that galaxies are not spread out evenly. Instead, they are found in long lines, clusters, and even bigger groups called superclusters. In between these big groups are huge spaces nearly empty of galaxies. The patterns in these maps help scientists understand how gravity and the expansion of space together created the shapes and clustering galaxies have today. Very special telescopes let scientists look deeper and deeper into the universe. Some telescopes are on tall mountains and others are in space, floating above Earth's air. These telescopes collect very faint light from the most distant places and can see galaxies as they were when the universe was young. When scientists see these distant objects, they are seeing billions of years into the past. Every new discovery fits the idea that the universe is getting bigger. There is no sign of an edge or border anywhere. The farther scientists look, the more clear it is that the same rules work everywhere. Galaxies move apart, clusters stretch farther away, and the patterns of redshift are found in every direction. These patterns match the theory of an expanding universe. The measurements of redshift are so accurate that scientists can use them to guess how the universe might change in the future. The numbers suggest the expansion will keep going for a very long time. Even now, the rate of expansion seems to be increasing. Galaxies that are far away will move away even faster as time goes on. The reasons for this are still being studied, but the redshift shows it is true. Scientists have also used redshift to learn about the universe's beginning. If you trace the expansion backward, you reach a time when everything was very close together. This supports the idea that the universe had a start, rather than having always existed as it is now. The discovery of the expansion from redshift is one of the most important ideas in the history of science. Sometimes galaxies do not move away from each other. If two galaxies are very close, gravity can be stronger than the stretching of space. In these cases, the galaxies can get closer together or even crash into each other. Our Milky Way galaxy, for example, will one day meet another galaxy called Andromeda. But when you look at large distances between groups of galaxies, the expansion always wins, and the groups move farther and farther apart. The evidence from redshift is very strong because it matches what is seen in so many other places. Scientists can see the stretching of light from supernovas, which are the bright explosions of dying stars. They also see patterns in the cosmic microwave background, which show the marks left by expansion. All of these clues fit together and give a clear message. The universe gets bigger over time. When scientists want to understand how fast the universe grows, they use something called the Hubble constant. This number shows how quickly galaxies at different distances move away from each other. By measuring this constant carefully using redshift and distance, scientists can estimate how old the universe is and how its size has changed. Redshift is not the only tool, but it is one of the most useful because light from galaxies at many distances all tells the same story. The stretching of space is not just a guess, it is something measured directly over and over again in every direction. It gives confidence that the idea of an expanding universe is correct. By using redshift, scientists have made a map of the universe as it gets older. The map shows young galaxies close together and older galaxies farther apart. This matches what is expected when the space between galaxies keeps growing larger with time. When scientists look at very far away galaxies, they are looking at the universe in past ages, seeing how it changed. All of the discoveries about redshift and moving galaxies are a reason why people now know the universe is not forever the same. It is always changing, always growing, and always making more space inside itself. The stretching of light is a simple proof of this change, and it connects what we see now with what happened billions of years ago. This knowledge has changed how people think about our place in the universe. Instead of seeing a quiet, unchanging sky, people now know they are looking into a universe that has a beginning, a history, and a future. Every galaxy is part of the story, and each bit of light that reaches us is a message from far away and long ago. Galaxies are like messengers telling us how space grows. Their light carries the clues. The more we look, the more we find evidence that the universe is vast, full of change, and governed by the same rules everywhere. The mystery of expansion becomes clear when we measure the redshift, see distant galaxies move away, and connect the past to the present. This kind of careful study will always be important because it gives us a way to keep learning about the universe. Every answer brings a new question. With every new telescope and every new way to measure light, scientists find more details, more patterns, and more proof that the universe grows in every direction, with no edge and with no end. When scientists measure the movement and distance of galaxies, they also face big questions about the size and shape of the universe. You might start to wonder if there is a farthest place you could ever visit. Many people ask if the universe has an edge, a border, or an ending. Some people wonder if there is anything outside the universe, or if it is surrounded by empty space, a wall, or some kind of barrier. These are natural questions. But the universe works in a way that is not like anything you find in daily life. If you look around your house or your town, everywhere you go there are limits. There are walls in rooms, fences around gardens, and borders on maps. Every object seems to have an outside or an edge. The universe is very different from all these things. The universe includes every object, every force, and all of space itself. There is no place, no point, and no line where the universe stops. When you look far, far away in any direction, all you ever see is more universe. You will never reach a wall, an ending, or a place where existence just stops and something else begins. No matter where you are in the universe, if you travel in a straight line, you will always find more galaxies and more space. The universe does not have an edge that anyone or anything can reach. Sometimes people imagine that there is empty space or some kind of void outside the universe. But this is not true. Even the idea of outside does not work for the universe. The only things that exist are inside the universe. There is no space outside, no time outside, and nothing at all that is beyond. The universe is not inside a bigger room. It is not a box, and it is not surrounded by emptiness. All the space and all the time that can exist are already part of the universe. When scientists use the word universe, they mean everything. This includes every star, every planet, every bit of matter, every particle of energy, all of the empty spaces in between, and even the flow of time from past to future. There is no outside meaningfully, because outside means nothing when there is nothing there. If you could somehow travel forever in one direction, you would never reach a border. Some forms of the universe may curve back on themselves, so that after a long time, you could return to where you started. But you still would never find an edge or a stopping point. The universe is all there is, and everywhere is inside. The universe does not have a shell, a frame, or a wall. The laws of nature do not suddenly stop working somewhere. The rules, like gravity, light, and the growing of space, work in every direction and at every distance. When you hear people talk about the size of the universe, sometimes they say the universe is infinite or endless. Right now, nobody is sure if the universe is truly endless. It might go on forever without repeating, or it might be very big but still have a special shape that does not repeat forever. Even if the universe is not infinite, it still does not have an ordinary edge or an outside. There is simply no border to reach. The same rules apply to galaxies. Galaxies do not live on the edge of the universe. Every galaxy is just one part of everything. Some galaxies are closer to us and some are farther, but all are inside the universe. If you could visit a faraway galaxy, you would find that the universe looks the same from there as it does from Earth. There is no special place where you can say, "This is the last galaxy." Every observer, no matter where they live and no matter which direction they look, will see more space and more galaxies. When scientists map the universe, they do not find an end. Even with their best telescopes, looking as far as light can possibly travel, they only see parts of the universe whose light has had enough time to reach us. This area, which is the farthest we can see, is called the observable universe. The observable universe is not a border or a limit of the whole universe. It is just the part we can see. The universe may be much bigger, and we just cannot see past a certain distance yet, because the light from farther away galaxies has not yet reached us. The observable universe has a size that can be measured. Its radius is about 46 billion light-years, which is a huge distance, but this does not mean the universe stops there. There may be much more beyond that, and there is no sign of a sudden stop or end point. The edge of what we can observe is not the edge of the universe itself. Sometimes people wonder if, beyond the edge of the observable universe, other things could exist, like more galaxies, different kinds of space, or even different rules. From what scientists can measure, there is no evidence of a change or a border anywhere. The rules of nature seem to be the same everywhere scientists can look. Every place that is far enough away is still just another part of the universe. Many ideas about the edge of the universe come from thinking about ordinary objects like balls, boxes, rooms, or planets. Every one of those things has a surface or an outside. But the universe is everything, so it does not have a place to sit in, and it does not have empty room around it. Mathematics is very important for understanding space. Scientists use math and observations together. They have found that according to their best measurements and ideas, the universe is all there is. The concepts of center, border, or edge do not fit. The universe does not expand into anything. It simply keeps creating more space inside itself. The expansion of the universe is not the same thing as stretching a balloon or filling a box. When the universe expands, it is not pushing into some strange place. There is no material, emptiness, or other kind of existence outside the universe to shape against. Instead, the distances inside are growing and all the changes happen within. Even the words beginning and end are difficult because before the universe began, there was no time or space. When people talk about the Big Bang, it means the moment when space and time began, not an explosion in empty space. Asking what is outside the Big Bang or what happened before is not the same as asking about borders in ordinary objects because there was no before and there is no outside. Some ideas try to imagine other universes or many universes called a multiverse. These ideas are interesting, but they are different from what can be measured or observed right now. From everything scientists can see, the universe is one single thing, and the words outside or edge have no physical meaning. The truth is that every place you can go, every direction you can travel, and every moment you can experience are all part of the universe. There are no hidden edges, borders, or limits hidden in the darkness of space. Time and space are joined inside the universe. And these are what everything is made of. Even when scientists build mathematical models and run simulations in computers, they do not find any proof of an edge. Some models show a universe that is infinite. Some show a universe that closes in on itself, like curving back to the start. But none show a stopping point where the universe ends and something else begins. If you were to fly a spaceship at the fastest speed that is allowed, and you went in a straight line for billions of years, you would not find a wall or an end. You might reach a place so far away that the stars and galaxies become too faint to see because their light has not reached you yet. But you would still be inside the universe. You would never run out of space. The universe gives more and more space as you go. There is no place to stand outside the universe and look in. The universe does not sit inside a bigger world or a dark outside. Even the idea of direction, such as up or down, has no meaning outside the universe because there is no outside space to compare to. Scientists use careful words to explain this. Nature does not have a border for the universe. All of the space, matter, energy, and time are inside. There is no edge, no limit, no border to reach or cross. If you hear about parallel universes or other dimensions, remember that these ideas do not change the fact that our universe includes all known space and all known time. Even if other universes do exist somewhere, there is nothing in science now that shows you can reach any outside area from this universe. The universe is its own reality with no way to travel past it. Every law of nature, every particle and every force is inside. Light, gravity, and time stretch through the whole universe. There is not a break, not a different set of rules, not a place where things stop working. The universe is a single connected whole. Even though people sometimes want the comfort of clear borders, the universe has taught us that nature is not always like the places and objects we see in daily life. Our planet has a surface, rooms have walls, islands are surrounded by sea. None of these ideas fit the universe. The universe is not a thing with a surface or a volume you can hold, measure, or explore from the outside. It is all of existence itself. Another question is whether the universe will ever stop, or if space itself has a kind of outer rim. From everything we know, there is no rim, no limit, and no stopping point in space. Space and time only exist inside the universe. When you hear about the universe expanding, remember that it does not stretch into a vacuum, an emptiness, or a nothingness. There is not even a void outside. The universe is simply making more space inside itself, so the distances between everything get wider. The idea of beyond the universe is just a word. There is no direction to walk or fly in that takes you past the universe, because that place does not exist. Even the biggest telescopes or the fastest ships would always be inside. There is no wall you could crash into. There is not even a border you could cross. Some people ask if there is a special place called the center of the universe. But there is no center. Every place in the universe is as important as every other. The universe looks the same in every direction, and no matter where you go, you are still in the middle of the universe from your own point of view. This is called the cosmological principle. It means there are no privileged spots, no special centers, and no special edges. Every part is just a part of the whole. When scientists map the universe, they see galaxies stretching out in every direction as far as they can look. These maps show no edge, no break, and no change in the rules. The shapes formed by galaxies may curve in some places, but they always connect back and share the same space. This unity is a feature of all the universe. Space, time, energy, and matter all began together with the Big Bang. They are all connected, and the history of everything flows forward inside the universe. There may be mysteries about what happened at the very start, but no scientist has ever found a wall, edge, or ending. As you think about everything in the universe, it can be amazing to realize there is nowhere you can go that is outside. You are part of a whole that has no boundary, no outside, no end. Even with all the technology and knowledge in the world, there is no path to the other side. All of science so far has shown that the universe is one, endless, and without a border. Every object, every force, and all the space, including the empty space, are part of the universe. If you ask, where does the universe end? The answer is simple. It does not end. If you ask, is there something outside? The answer is that there is not even an outside. In every measurement, in every observation, these facts remain true. As scientists keep learning, they may discover new mysteries and new parts of the universe, but the lesson is always the same. The universe contains everything, and there is no edge, no wall, and no limit waiting for us beyond. No matter how far we look, we always see more universe, more space, and more possibilities. Even though the universe has no edge and no outside, it is always getting bigger inside itself. This growth of space has important effects on what happens to the things living inside the universe, like galaxies, stars, and planets. These things are not floating alone. They are held in place by powerful forces, and their movement is part of the story of expansion. As the universe keeps growing, galaxies move farther away from each other, but the galaxies themselves do not break apart. Each galaxy is a collection of stars, planets, gas, dust, and dark matter. All these pieces are pulled together by a force called gravity. Gravity is one of the most important forces in the universe. It works over huge distances and holds galaxies together. It also causes stars to circle around the centers of galaxies and planets to orbit stars. Even though space is growing, the force of gravity inside a galaxy is much stronger than the gentle stretching of space. That is why, as the universe expands, galaxies stay together instead of being pulled apart. The space between one galaxy and another galaxy in a different group is getting bigger, but inside a galaxy, gravity keeps the stars close. Each galaxy has its own shape. Some are spiral with long arms. Some are round and smooth, called elliptical galaxies. Some look messy with many twists. All these different types of galaxies are made of billions or even trillions of stars. In one ordinary galaxy, such as the Milky Way, there are stars, planets, clouds of gas, and many other objects. Inside the galaxy, the stars move around the center, pulled in by gravity. Inside every galaxy, there are smaller parts called solar systems. Each solar system has one or more stars in the middle and planets, moons, and other objects going around it. Our solar system has the Sun in the center. Earth is one of the planets going around the Sun. The distance between Earth and the Sun does not keep growing because of the expansion. The force of gravity between the Sun and the Earth is much stronger than the expansion of space. In everyday life, the expansion of the universe does not change the way people, planets, or even galaxies behave on small scales. When people measure the distance from Earth to the Moon, from one city to another, or even from one side of the Milky Way to another, those distances are controlled by local forces. Gravity and other forces, like the ones between atoms and molecules, are so powerful that they easily beat the gentle stretching of space. The growing of space can only be seen when you look at the huge gaps between clusters of galaxies. Clusters of galaxies are very large groups. Each cluster can contain hundreds or thousands of galaxies, all pulled together by gravity. Inside a cluster, the galaxies move around just as stars move around inside a single galaxy. The space between clusters, however, does grow larger over time. Space expands most strongly where gravity is weakest, and this happens mostly in the large stretches of space between clusters. If you could imagine watching the universe for billions of years, you would see the groups of galaxies drift farther and farther apart. Inside the clusters, though, galaxies continue to move around each other, and inside each galaxy, the stars keep following their paths. Nothing inside these huge groups is pulled apart by the expansion, because gravity inside clusters and galaxies is strong enough to hold things together. The same is true for smaller scales. Every atom that makes up your body, or the ground, or the air, is held together by forces that are much stronger than the expansion of the universe. Space does not grow between the pieces inside an atom, nor does it grow inside a rock, a planet, or even inside small clouds of gas. The forces that hold atoms together are called the electromagnetic force and the strong force. Both are much greater at small distances than the force of expansion. As a result, all familiar objects, people, trees, cars, buildings, do not grow or break apart because of the universe's growth. This is why the expansion is something noticed only on the very largest scales. The farther you look, the more you see the galaxies and clusters drifting away from each other. The closer you look, the less effect the expansion has, because other forces are much stronger. In every galaxy, stars live their lives, form, shine, and eventually die. Galaxies sometimes pass close to each other, and gravity might make them come together and merge. This can happen even as the universe is getting bigger, because the force of gravity between two galaxies can be stronger for a short time than the stretching of space. In the future, our own galaxy, the Milky Way, will meet the Andromeda Galaxy. They will merge to form a new, larger galaxy. Events like this happen sometimes, but mostly, as the universe grows, galaxies move apart. Galaxies are the main places where stars are born. When clouds of gas inside a galaxy get thick enough, gravity pulls the gas together and new stars form. Some galaxies form many stars every year, others are quieter with only a few stars born now and then. As time passes, the stars use up the gas and the galaxy may slow down in making new stars. The history of every galaxy is shaped by the stars forming inside, living, shining, and then dying in different ways. When stars reach the end of their lives, they can explode or shrink down. These events can send material out into the galaxy, where new stars might form from the pieces. The cycle of birth and death of stars is an important way that galaxies change over time. Even though space is growing, the stars inside a galaxy keep being born and dying, held together by gravity the whole time. Inside solar systems, planets move around their stars, and moons circle planets. These paths keep going the same way for millions or even billions of years, because the forces inside the system are strong enough to fight off the gentle stretching of the universe. The distance between planets and their star does not increase because of the universe's growth. Planets keep their orbits, and the solar systems stay together. The expansion of space only stretches the distances where gravity and other forces do not hold objects close. Empty areas between clusters of galaxies are where you see the effect. Over long times, these gaps grow larger, making the universe seem more empty when you look at the biggest scales. But when you look at things like galaxies, solar systems, or atoms, the stretching does not change anything. When scientists study the universe, they build maps showing where galaxies and clusters are. These maps reveal large patterns in the universe. In some places, groups of galaxies are close, forming filaments and walls. In other places, there are large empty spaces called voids. The expansion of space means the distances between these groups get bigger over time, but inside each group, everything stays held together by gravity. The behavior of galaxies and clusters helps scientists understand the balance between gravity and expansion. If gravity inside a group of galaxies is strong enough, the group stays together in one cluster. If galaxies are too far apart, the stretching of space will be stronger than gravity, and the galaxies move away from each other. This balance explains why there are big groups, but also big empty places as the universe grows. The growth of the universe also means that the light from distant galaxies and stars is stretched as it travels through expanding space. This stretching of light is called redshift, and it helps scientists measure how fast galaxies move away from each other. The larger the distance between galaxies, the greater the redshift. Scientists use this fact to learn how the universe changes over time and to trace the growth of space itself. As space gets bigger, it becomes harder for the light from the most distant galaxies to reach us. There may come a time when the distances become so large that light from some galaxies can never reach us again. This means that, in the very far future, parts of the universe will no longer be able to see each other. The universe will seem more empty, even if galaxies themselves still exist and are full of stars and planets. Even though the universe is always making more space, this does not make planets, stars, or galaxies themselves grow larger. The matter inside these objects is held tightly by strong forces. The forces stop the expansion from having any effect inside objects. No one feels pulled apart by the expansion because it is far too gentle to break apart things like people, houses, or planets. Every galaxy, no matter how far away, is part of this process. Galaxies in clusters move together, and the clusters get farther apart as the universe expands. Inside galaxies, the stars, planets, and dust keep going in their paths. Some galaxies are young with many bright stars, and others are old with only a few new stars forming. The expansion of the universe affects them all in the same way, by changing the space around them, but not breaking them apart. The energy that drives the expansion is part of the universe itself. There is not an outside force pushing from beyond. The stretching of space comes from how energy and matter behave inside the universe. Over time, scientists have learned that a kind of energy called dark energy might be the cause of the acceleration in the expansion. This dark energy makes galaxies move apart even faster as time goes on, but it still doesn't pull apart things held by gravity or other strong forces. Studying clusters and the movement of galaxies also helps scientists learn about invisible matter, called dark matter. Dark matter cannot be seen with light, but its gravity helps hold galaxies and clusters together. Scientists know it is there because of how galaxies rotate and how clusters behave. Without dark matter, galaxies would not stay together when turning as fast as they do. The gentle expansion of space affects even areas with lots of dark matter, but gravity created by dark matter adds to the overall strength holding things together inside a cluster. When you look at all of this, you see that the universe is made of many connected parts. On the very largest scales, space keeps growing and changing the distances between clusters of galaxies. Inside those clusters, gravity keeps galaxies together, and inside galaxies, stars stay close. Solar systems work on their own, and atoms stick together in rocks, planets, and living things. The gentle stretching of the universe is always there, but its effects are only visible when you look at distances across millions or billions of light years. Each part of the universe follows the same rules and takes part in the same growth. There are no breaks, borders, or different laws in different places. The universe stays together as one system, joined by gravity and other natural forces, no matter how big it becomes. Even though some galaxies will merge and new stars will form or die, the universe's expansion is always in the background. The distance between the closest groups grows larger, but what lies inside each galaxy and cluster is safe from the pulling of space because gravity wins. Over time, the space between the biggest objects grows so much that it takes longer and longer for light and gravity to cross the gaps. The story of the universe is also the story of how things stay together even while space gets bigger. Gravity and other forces keep the small worlds safe and whole. The expansion gives room for new things to form, light to travel, and galaxies to change and move. It never pulls apart planets, stars, or the matter inside you. The universe contains all things, and as it expands, galaxies move apart while galaxies themselves remain whole. Even clusters tied together by the joined gravity of many galaxies resist being pulled apart. The empty spaces between these clusters, though, become wider and emptier with each passing billion years. Every new birth of a star, every merging of galaxies, every journey of light through space happens inside this growing universe. The patterns of where things are and how they move are shaped by the balance of gravity and the stretching of space. The universe's gentle and steady growth means the history of stars, galaxies, and planets is always changing, but their structure stays strong. In this vast and growing cosmos, every person, planet, and star is connected through gravity, through history, and through the space that keeps growing between all things. The forces that hold everything together work everywhere. Space grows, galaxies drift apart, new stars are born, and old ones die, but the small worlds and the lives inside them remain safe, bound together by forces much stronger than the gentle push of expansion. All the connections that hold galaxies and clusters together, and all the ways the universe grows, are found through observation and careful measurement. Scientists need to know not only that the universe is expanding, but also how fast and how much the distances between galaxies are changing. To understand this, special methods are used to measure both the light coming from objects far away and the positions of these objects in space. The main tool used for measuring the expansion of the universe is the telescope. The first telescopes were simple, but now scientists build very large ones on mountain tops and even send telescopes into space far away from Earth to avoid atmosphere. When a telescope gathers light from galaxies, it lets scientists see what these galaxies looked like when their light began its journey. This light carries information about what was happening in the distant past, because light takes a very long time to travel from faraway galaxies. Scientists use instruments called spectrographs with telescopes. A spectrograph spreads out the light from a galaxy into a long band of colors. This band shows special marks called absorption and emission lines. Each kind of atom and molecule makes its own pattern of lines. When these lines are shifted toward the red part of the color band, that means the light has been stretched during its travel. This is called redshift. By measuring the redshift, scientists know how much the universe has grown while the light was moving to us. To measure redshift, scientists carefully study the positions of certain lines in the light from a galaxy. They compare the lines they see in the light from far away to the lines from the same kinds of atoms measured in a laboratory here on Earth. If the lines are in a new position, shifted towards red, it tells scientists the galaxy is moving away and that the space between us and the galaxy has expanded. The more distant a galaxy is, the higher its redshift. That means the light from very far galaxies is stretched more than the light from nearby galaxies. The amount of stretching shows the speed that each galaxy seems to be moving away from us, and it tells how much the universe has expanded since the light left the galaxy. This process is repeated for many galaxies in all directions. To know how fast the universe is growing, scientists compare redshift with another measurement: distance. Distance in space is not easy to find because the objects are so far away. Scientists use different methods depending on how far away the galaxy is. For nearby stars, they use parallax, which is measuring the position of a star from different places and times as the Earth moves around the Sun. This shows how much a star seems to move against the background. For more distant stars and galaxies, parallax is not enough. Scientists use objects called standard candles. The best known of these are special types of stars called Cepheid variables and supernovae. These objects have known brightness. By finding how bright they appear to us and knowing how bright they really are, scientists can calculate their distance. This is because the farther away an object is, the dimmer it looks. The method works like this. If you see a light that you know is very powerful, but it looks faint, you know it is far away. Using standard candles, scientists can measure distances to many galaxies. When the distance and the redshift for a galaxy are both known, they can be compared. For many galaxies at different distances, scientists looked at this relationship and found that the farther away a galaxy is, the bigger its redshift. This shows that space is stretching between us and all the galaxies. This pattern lets scientists define the Hubble constant. The Hubble constant is a number that tells how fast the universe is expanding at the present time. The value is found by looking at many galaxies and seeing by how much space between them is growing for each million light-years of distance. Scientists work to make measurements more and more accurate, sometimes finding small differences depending on the method or the kind of object used. To help measure even farther, new telescopes study light that is invisible to the human eye, such as infrared, ultraviolet, radio waves, and X-rays. Some galaxies and cosmic events make light that is best seen in these forms. For example, the James Webb Space Telescope is especially sensitive to infrared light, which is stretched most by the expansion. This helps it see very distant, very old galaxies whose light has traveled for billions of years and has been stretched a lot by the time it reaches us. Scientists also use methods called galaxy surveys. In a galaxy survey, large numbers of galaxies are studied and their positions are carefully mapped, along with the colors and redshifts of their light. Some of these surveys use telescopes that scan large sections of the sky, collecting data on millions of galaxies over many years. With these surveys, scientists can build a three-dimensional map of the universe, showing how galaxies are arranged in space and how space is expanding everywhere. One famous survey is the Sloan Digital Sky Survey. Using this survey and others, scientists found how galaxies gather together into long chains called filaments, large groups called clusters, and very big empty places called voids. These maps make it possible to see the pattern of where matter is in the universe and how large empty spaces are growing as space expands. Besides light from galaxies and stars, scientists also use special signals called gravitational waves. These are tiny changes in space itself, caused by very violent events like two big black holes crashing together. When gravitational waves reach Earth, they can be measured by sensitive instruments. These waves also give scientists new ways to learn about distances and to check that the measurements made using light are correct. All the different ways of measuring — parallax, standard candles, redshift, galaxy surveys, and gravitational waves — agree with each other and support the idea of a universe that is growing everywhere. The agreement of many methods gives confidence that the science is correct, even when it is hard to imagine. To measure very old light, scientists study the cosmic microwave background. This is light that was made when the universe was only about 380,000 years old. At that time, the universe was much smaller and hotter than it is now. As the universe grew, this ancient light was stretched so much that it is now very cold and faint, seen today as microwaves. Scientists use special space telescopes like the Planck satellite to take pictures of this light from every part of the sky. The cosmic microwave background is very smooth. but it has tiny changes. These changes show how matter and energy were spread out long ago. Scientists use this information to learn how fast the universe was growing in the past and to measure things about the universe, like how much matter and energy it contains. All these details fit together with the measurements from galaxies, standard candles, and redshift. With these tools, scientists can build a timeline for the universe. They can tell how long the universe has been expanding. Today, the best measurements show that the universe is about 13.8 billion years old. This means space has been growing for all those years since the Big Bang. By measuring how fast it grows now and how things changed in the past, scientists can also make predictions for what will happen in the future. Measuring expansion is a job that needs great care. Even small mistakes can make a difference in answers about how big the universe is or how old it is. That is why many different groups of scientists compare notes and use different methods to check their results. When a new telescope is built or a new way of measuring is invented, scientists check if past results still hold true. Some mysteries remain, like small differences in the value of the Hubble constant, depending on whether it is measured close to us or from very old light in the cosmic microwave background. These puzzles are being studied and might teach us new things about space, time, or the hidden parts of the universe, like dark matter and dark energy. New generations of telescopes and instruments help scientists look deeper into space and farther back in time. Each improvement in technology opens more of the universe to study and makes measurements of expansion better. Computers help by handling huge sets of data gathered from telescopes and by building pictures of how the universe might look at different points in time. Careful study of light and distance allows scientists to test ideas about the universe. If something did not match, new discoveries would be needed, but so far all the evidence supports the idea of never-ending expansion and a universe with no edge or outside. The same laws and rules work everywhere that has been measured. The way that space grows and light travels has another effect. The farther away a galaxy is, the younger it looks to our eyes. This is because the light left the galaxy so long ago that we see it as it was billions of years in the past. By putting many measurements together, scientists can see how galaxies grew, changed, and moved as the universe expanded. Scientists use the results to understand what kinds of matter and energy are present in the universe. Notice that measurements not only show how the universe expands, but also help scientists see how things changed over time, what forces push expansion, and how gravity and dark energy work. One important part of the universe is dark matter. Dark matter is invisible but has gravity. By measuring the movement of stars, galaxies, and gas clouds, scientists know dark matter must be there because things move faster than they would if only visible matter were present. Measurements from redshift, galaxy shapes, and light bending around clusters help scientists find how much dark matter is around. Another part is dark energy, a kind of energy that pushes the expansion faster. Measurements of very distant supernovae showed that the expansion of the universe is not only continuing, but is getting faster over time. This result was found by comparing the distances and redshifts of hundreds of supernovae. It was a surprise, but it helps explain why the farthest galaxies seem to move away so quickly. As scientists measure the universe, they look for all the parts that make up space: visible matter, dark matter, radiation, and dark energy. Using maths and measurement, they can tell how much of each is present and what part each plays in the story of the universe's past, present, and future. The science of measuring growth in the universe uses teamwork. Groups of scientists from many countries share their observations and compare results. Big telescopes are often used by scientists all over the world, and the data becomes public so many groups can look for truth. This way, the facts discovered can be checked and tested by everyone. As technology improves, scientists hope to answer new questions like what causes dark energy, how dark matter is made, and why expansion is happening in this particular way. Even now, every new sky survey and every fresh look at ancient light adds more to humanity's understanding of the universe. All of these measurements, light, distance, redshift, standard candles, cosmic background maps, are important. They work together to show a consistent story about an expanding universe. Everything that can be seen, measured, or detected lines up with the idea that the universe is getting bigger. There is no edge, and all growth happens inside the universe. From these observations, scientists study how galaxies came to be where they are, why the universe looks the way it does today, and how much it has changed over time. Maps show the positions of millions or billions of galaxies, tracing a pattern of growth that matches theories built from the data. With special attention to detail, the mysteries of space are studied and checked, always moving closer to understanding more about the growing universe. Each discovery is a small step, another piece of the puzzle. The work never ends because each answer opens a door to new questions, leading scientists to look deeper, measure more precisely, and learn more about the wonderful, expanding universe we all live in together. Every new piece of information scientists find helps them build a picture of how the universe has changed from the distant past until now. When scientists look at the oldest light and measure the positions of galaxies, they are seeing not just a single moment, but a story that goes back a very long time. This story begins with a universe that was very different from the one we see today. The early universe was much smaller, much hotter, and everything in it was packed much closer together. A very, very long time ago, about 13.8 billion years in the past, space and time began together during the event called the Big Bang. In those first moments, everything that would ever become planets, stars, and galaxies was squeezed into a space that was much smaller and much denser than anything we see now. It was very hot, so hot that no atoms, stars, or planets could exist yet. Only tiny pieces of matter and very strong energy filled the universe. As soon as the universe began, it started to expand very quickly. Space stretched out, becoming bigger in every direction. This process happened at an incredible speed during a phase called inflation. Inflation did not push matter into empty space. There was no outside, but made more space everywhere at once. As this new space appeared, everything in it moved apart from everything else. When the universe was still very young, much less than 1 second old, it was full of energy and simple particles moving in all directions. There were no atoms, no light that could move freely, only energy and simple ingredients that would one day build everything else. After a small amount of time, the universe began to cool down a little. This cooling allowed particles to come together to form protons and neutrons. These are the building blocks of atoms. But everything was still too hot for real atoms to exist. Light could not travel far because free electrons would block and scatter it. Every point in the universe was filled with a bright, hot fog. After about 3 minutes, the universe was cool enough for protons and neutrons to join and form atomic nuclei, the hearts of atoms. In these early minutes, almost all the matter became the simple types we know as hydrogen and helium. Still, atoms were not complete. Electrons kept moving free, so the hot fog remained. This fog covered the whole universe for hundreds of thousands of years. Then, when the universe was about 380,000 years old, things changed. The universe had cooled enough that the free electrons could finally connect to atomic nuclei and make complete atoms. This moment is very important because now light could move through space without always being stopped. That first free light has traveled ever since that time. Today, the universe is filled everywhere with a very faint glow called the cosmic microwave background. This is the leftover light from that early moment. When scientists look at this light, they can still see the small changes and tiny patterns made when the universe was young. The weak glow of the cosmic microwave background is a message from the past that tells us what the universe was like long, long ago. Once light could travel freely, the universe entered a new age. Matter could come together more easily because nothing was blocking it all the time. Over the next hundreds of millions of years, matter slowly began to join into larger and larger groups. Small changes in the early fog meant some places had a little more matter than others. Gravity pulled matter toward these places, making those regions grow and collect more material. As these little clumps of matter grew, they became the first stars and galaxies. The first stars were made when clouds of hydrogen and helium became heavy and dense enough for gravity to squeeze them together. When stars formed, their powerful light started to shine and changed the whole universe. The light from these early stars was strong enough to break apart hydrogen atoms in the surrounding space. This made the universe less dark and more transparent, allowing even more light to move between the first galaxies. The very first galaxies formed by joining together many stars. These first galaxies were small, but over time galaxies grew by pulling together more stars, more gas, and sometimes by merging with other galaxies. This process happened everywhere space existed. The expansion of the universe meant that these galaxies were moving away from each other, even as each galaxy grew bigger by itself. As stars lived and died in the first galaxies, they changed the universe even more. When the first stars died, they exploded. These explosions sent new elements like carbon, oxygen, and iron into space. These new materials mixed with gas clouds and made it possible for new kinds of stars and planets to form. The story of the universe is also the story of how simple matter became more and more complex because of the lives of stars. During the first billion years after the Big Bang, the universe saw great change. Little clouds became stars. Stars joined into galaxies. Galaxies pulled in more materials and merged to become larger galaxies. Gravity was the main force behind all this movement and growth. As galaxies got bigger, they also began to form large groups called clusters. Clusters became important in holding many galaxies together, even as space kept getting larger all around them. The light from the first generations of stars and galaxies is very faint by the time it reaches Earth. Scientists use very powerful telescopes to look as far away as possible, trying to see the earliest galaxies and the oldest light. When astronomers find a distant, faint galaxy, they are really looking backwards in time, seeing the galaxy as it was billions of years ago. Each discovery helps scientists learn more about how the early universe changed and grew. By studying the oldest galaxies, scientists discovered that long ago, galaxies were much closer together than they are today. The sky would have looked very different back then. There would have been more bright objects close together, and space was more crowded. The farther back in time you look, the smaller and denser the universe was. The universe did not stay the same. Its temperature dropped as it grew. The early universe was so hot and dense that atoms could not exist. Then it became cool enough for atoms to form, then even cooler until stars and galaxies could shine. The pattern of growing and cooling continued. As expansion spread out the matter and energy, the universe became less crowded and less hot. Galaxies did not stay small. Over many billions of years, galaxies changed by joining with other galaxies. Sometimes two galaxies passed close and gravity pulled them into each other. When galaxies merged, they made bigger galaxies with more stars. Huge galaxies like the Milky Way are results of many smaller galaxies joining together over long periods. Clusters of galaxies formed in the same way as groups of galaxies pulled together by gravity. Some clusters are hundreds or even thousands of galaxies strong. Inside clusters there are very large amounts of mass, including dark matter, which cannot be seen but whose gravity can be measured. The expansion of space means clusters move apart from other clusters over time, but each cluster stays together because of the gravity holding it tight. Inside galaxies, the first generations of stars sent out strong light that helped make the universe clear and bright. When each star reached the end of its life, it left behind new types of matter for planets and future stars to use. Over billions of years, more and more complex elements and chemicals appeared inside stars and then traveled into space to become part of new planets and living things. After a few billion years, the universe contained enough of these new materials for rocky planets to form around some stars. The Sun and the Earth are younger members of this long history. Our solar system formed about 4.5 billion years ago, which is much younger than the oldest stars. The Earth and all life here are built from material made in even older stars, which lived, died, and mixed their elements into the galaxy. The history of the universe is a story of small changes happening one after another. The first stars made light. That light changed the nearby universe. Those stars exploded, sending out new materials. New stars and planets were made from those materials. Larger and larger groups came together. Stars into galaxies, galaxies into clusters, clusters into even larger structures across the sky. Each stage changed the appearance of the universe. Early on, the sky was crowded and bright. As space grew, galaxies moved farther apart. Life formed on at least one small planet, Earth, but maybe on others we cannot see. Everything that now exists traces back to the early times when all matter and energy was packed close together. Scientists know the universe changed by looking at the light from the most distant galaxies and from the cosmic microwave background. These lights are full of information about the conditions in the past. The faint fingerprints left in these lights show how matter was spread out, how things began to clump together, and how new objects were born. Since the first billion years, the universe has slowed down in making new stars. Most of the stars you see in the night sky are already billions of years old. New stars are still being born in some galaxies, but the rate is slower than it was in the earliest times. Galaxies now are bigger, often older, and spread farther apart than before. The space between galaxies also became less crowded. The expansion of the universe has stretched out those distances, making the empty gaps grow wider as time goes on. It takes longer and longer for light from the most distant galaxies to reach us today, and some galaxies have already moved so far away that their light will never get here at all. The history of the universe is not finished. Every day new stars are born and old stars die. Galaxies grow and change. The universe keeps getting bigger, making more space between the largest structures, even as gravity keeps each galaxy and cluster together. The cosmic story never stands still. Scientists keep working to learn more about how the universe has changed over time. Each new telescope looks farther into the past. Each new map shows new groups of galaxies or signs of ancient explosions. By putting all the observations together, scientists build a moving picture of the universe. A picture that starts as tiny, hot and crowded, and becomes wide, cool, and full of galaxies scattered far apart. As the universe got older, it also cooled. The earliest universe was so hot, nothing we see today could exist. But as it expanded, the temperature dropped, and the structures we know, atoms, stars, galaxies, planets, life, could slowly form. Without the expansion, the universe would never have cooled or grown enough for us to exist. When scientists look at the universe now, they see not just things as they are, but clues about how they used to be. Every star, every galaxy, and every planet is like a page in the big story of space and time. By studying them, we learn what happened in the distant past and how it made everything we see around us now. The journey from a hot, crowded beginning to an old, wide universe is told in the light that reaches us, in the patterns of stars, and in the clusters of galaxies. The story is always growing longer as more space appears, as more stars form and die, and as the universe changes all over again each day and night. From the tiniest atoms formed in the first minutes after the Big Bang to the biggest galaxy clusters that drift farther apart each billion years, every part of the universe's story connects with every other part. The early universe was a place of blazing hot energy and growing space. Today's universe is a quiet, expanding place full of galaxies, stars, planets, and empty space. And in this story, every part that exists today came from what happened in that long, unfolding past. The history of the universe is long and full of changes, but the process of expansion is not finished. The universe is still growing, and this will shape what it becomes in the far future. Scientists do not just look at the past, they also use what they know to think about what is ahead. The universe's future depends on the rules of expansion, the role of gravity, and something called dark energy. As the universe continues to grow, the space between clusters of galaxies becomes wider and wider. Galaxies that are close together and held by gravity, or that are part of clusters, will stay close, but galaxies that are far apart will keep moving farther away from each other. This is because the stretching of space does not slow down. In fact, it is speeding up. The reason for this speeding up is dark energy, a special kind of energy that scientists do not fully understand, but can measure through the way expansion is changing over time. The more space grows, the less crowded the universe becomes. Light from very distant galaxies takes longer to reach us. As expansion speeds up, some galaxies are moving away so fast that their light will never reach Earth. Each year, more galaxies cross this limit, called the cosmic event horizon. Galaxies that pass this point are no longer visible and can never be visited, even in imagination. The universe will look emptier from any one galaxy as time goes on. Right now, most galaxies we can see are moving away from us, and most will never meet our galaxy. Only a small group of galaxies that are close and held by gravity will remain near us for a long time. In billions of years, even these close galaxies might join together to form one large galaxy, but the space between this group and all the others will stretch so far that almost nothing from the outside will ever reach it again. If someone lives in a galaxy far in the future, their night sky will look very different. Long ago, they could have seen many galaxies as small dots of light. Far ahead, those other galaxies will move so far away, and their light will be stretched out so much that they will become too faint to see. The universe will appear much darker and lonelier for any future observer. There will still be stars, but they will be almost alone in the sky. The stars themselves will not last forever. Stars are born, live for a time, and then use up their fuel. Some stars shine for only a few million years, while others, like red dwarf stars, can keep shining for trillions of years, much longer than stars like our Sun. In the deep future, most of the bright, hot stars will burn out. New stars can still form for a while, but as gas and dust are used up, fewer new stars will be born. After enough time, nearly all that remains will be dim, cool stars. As the universe gets older, more and more of its light and energy will be lost from each galaxy. When stars die, some become white dwarfs, neutron stars, or black holes. These objects do not shine with much visible light. Over many trillions of years, the bright stars will fade and the universe will fill with cooler and dimmer objects. Black holes, which come from the heaviest stars or from the centers of galaxies, will last the longest. Over unimaginably long times, even black holes will slowly lose their energy through a very slow process called Hawking radiation. After much more time, they too will vanish. As cosmic expansion continues and dark energy pushes space to grow even faster, all the galaxies beyond the local group will move away so quickly that their light can never reach us again. If anyone is living at that time, they may not even know other galaxies ever existed, because there will be no way to see their light or tell that old galaxies are out there. In this far future, whatever stars and planets remain will be the last islands of matter in an ever-growing sea of space. Stars that can last trillions of years may give off a little heat and light, but there will be no new young galaxies and no new bright stars forming from fresh clouds of gas. The space between what is left will grow so wide, and the night sky will be so empty that the visible universe will shrink just to the local matter. The cosmic microwave background, the faint light that fills the universe from the early days after the Big Bang, will also change. As space grows, its light will be stretched out more and more. It will become colder and shift to wavelengths impossible to detect with any tool that could ever be built. It will fade away, and the last traces of the earliest light will be hidden by the expanding space. Even in this empty-looking universe, gravity will keep some things together. The objects near each other in one galaxy, or the group of closest galaxies, will slowly drift together and merge. Each time galaxies merge, their stars mix and new patterns form. But with so few bright stars remaining, most things will look dim and calm. The future also means fewer and fewer chances for new life to appear. Planets need energy from stars to be warm enough for life. When the last long-lived stars finally fade, any life anywhere in the universe will need to live without starlight. If life can survive on small stars and use their gentle heat, it could last for an extremely long time. But after many trillions of years, even these stars will grow cold and dark. The universe will then be full of dead stars, black holes, and tiny bits of cold matter. Scientists give this possible end many names. Some call it the heat death, others the big freeze. That name means the future universe will be so spread out and so cold that almost nothing else can happen. There will still be space, time, and matter, but movement and change will mostly stop. There are other ideas for how the universe could change in the distant future. Some scientists wonder if the expansion might someday slow down or even reverse. But the evidence today shows that dark energy will keep pushing expansion forever. Other ideas include changes in dark energy that could make space expand much faster or in a new way. But for now, the evidence fits with a universe that becomes colder, darker, and emptier with time. This future does not have big edges, walls, or any new space outside. Just as in the present and past, everything that exists will always be inside the universe. The only thing that changes is the size and emptiness between objects. Space will keep growing, but there will not be anything outside, no other space to enter, and no place to reach beyond the universe. If the universe keeps expanding forever, the distances between galaxies will continue to grow. With time, stars will not see each other, and galaxies will not see each other, and objects will become lonely. The fundamental rules of gravity, motion, and the behavior of energy will still hold everywhere in space and in every moment. All the knowledge about the future comes from measuring the universe today, looking at how far galaxies are, how fast they move apart, and how the oldest light has changed. The same tools that help us learn about the past also help us guess what is going to happen ahead. Each new measurement teaches more about how the universe works and what the distant future may be. People, planets, stars, and galaxies will all be part of this future. Our own galaxy and its close neighbors may join to make one bigger galaxy in several billion years. But even this large galaxy will find itself alone in the sky after enough time. The stars that remain inside it will light up the darkness for a while, then slowly go out one by one, leaving space almost completely black. The flow of time, the growth of space, and the way energy acts mean that the universe is always moving in the direction of more emptiness, less warmth, and fewer bright things to see. But even as things grow apart and the sky grows quiet, the expansion of the universe will never stop. The story goes on as space keeps stretching farther and farther. More mysteries may still be solved in the future. The nature of dark energy is not fully known. If scientists find out how and why it works, or if its power ever changes, the universe's future story might also change in ways no one expects yet. For now, all measurements and evidence suggest that growing space and more distance between galaxies and stars will be the pattern for all time. The expansion of the universe shapes not only what we see, but what is possible. Today, scientists can look out and see billions of galaxies, but in the far future there may be no way for anyone to see beyond their own. The stars will still tell the story of the universe's past, but much of the detail, the far galaxies, the oldest light, the pattern of clusters, will slowly vanish from sight. Long after the last bright star goes out and all the faraway galaxies have left our view, space itself will keep growing. Time will pass, energy will get colder and more spread out, and only the smallest, coldest objects will remain. Even so, this space, this time, and this universe will still be all there is. There will be no edge or border to reach, only more of the same universe, cold, empty, and quiet. All of these ideas about the future are built from watching what happens in space right now. Scientists use the movement of galaxies, the faint messages from early light, and the pattern of expansion to look ahead as well as behind. With each improvement in measurement, they get a better picture of where the universe is going and how it might look, not just in a million years, but in millions of billions of years. None of these changes mean the universe stops existing. Expansion is simply a change in distance and emptiness between things. The rules that shape matter and energy keep working, and space keeps making more room as time moves forward. There is no sign of an ending. There is only more as the universe grows older and wider, a process that continues far into the deepest future. Everything that exists, each galaxy, star, planet, and atom, will take part in the next stages of cosmic history, shaped by expansion and by the rules of nature. The universe will still have no border, no wall, and no outside to reach. No matter how empty it becomes or how much time passes, the growth of space is an endless process, gently carrying all objects farther apart in a universe that always contains all of space, all of time, and all that can ever exist. Each moment that passes is part of the universe's long history. The expansion of space has shaped everything. The birth of stars, the building of galaxies, and the ways objects move apart. Scientists use observations and measurements to explore these changes, seeking simple explanations for how the universe began, how it grows, and what keeps everything connected. What do scientists really know, and how do they understand the idea that the universe expands? Every piece of evidence starts with a question about what we see and feel. When people look into the night sky, they see stars, planets, and the soft, dark space between them. But the light from far galaxies is not just a pretty sight. That light gives clues about distance, movement, and time. Scientists use telescopes to look further, collect more light, and build careful maps of the sky. The most important discovery is that space itself can grow. Space is not just a background or an empty shell. Space is part of the universe, and it follows the same rules as everything else. When scientists measure galaxies, they find that the space between galaxies increases as time moves forward. The galaxies are not being pushed out into something else. It is the space between them that becomes bigger. Inside each galaxy, forces like gravity keep stars together, but the space between groups grows larger. Scientists use many methods to learn about this growth. By looking at how the colors of distant galaxies are stretched, they learn how fast space is growing. Other measurements, like the brightness of special stars or the faint echo of the cosmic microwave background, show how the universe used to look, how it has changed, and how old it is. By putting all these facts together, they find that the universe began about 13.8 billion years ago and has grown ever since. The idea that the universe has no edge, no border, and no outside makes it different from anything people see in daily life. Everything around us, like houses and roads, has boundaries. The universe has no such limit. In every direction there is more space, and all space is part of the universe. There is not even empty space beyond it, because space only exists inside the universe itself. This kind of thinking is new for most people, but every time scientists build a new kind of telescope or invent a better way of measuring, they see the same thing. There is no edge. There is no wall. Galaxies do not move into emptiness. The stretching of space happens everywhere, and it happens the same for every galaxy and every observer. The expansion does not change everything in the same way. In small places, like your own body or a single star, other forces are much stronger than expansion. Gravity, the electromagnetic force, and atomic forces all keep objects and matter whole. That is why our planet, our sun, and even our own atoms do not get pulled apart as space expands. Only over the greatest distances between clusters of galaxies does the gentle stretching of space become stronger than the pull of gravity. This is why the universe can grow for billions and billions of years and still keep galaxies and stars close together in clusters. The delicate balance between stretching space and pulling gravity shapes what we see. Empty stretches between groups of galaxies, groups held tight by gravity, and the spread of matter that matches the earliest patterns seen in the oldest light. The expansion of the universe is not just an idea. It is supported by everything that scientists can measure. They look at the redshift of galaxies. They use standard candles like special stars to work out distances. They study the ancient cosmic background light to see how the early universe looked. All these signs point in the same direction. The universe is expanding, has been expanding for billions of years, and has no border or outside. From observations, scientists measure numbers like the Hubble constant. This is a number that tells how fast the universe is growing today. It links the redshift of faraway galaxies to their distance. When scientists compare values from different ways of measuring, they get results that support the expansion. Tiny differences are still being studied, but the story of a universe that grows inside itself remains the best explanation for everything seen. The story of the cosmos is also the story of patterns. The way galaxies are arranged in lines and clusters comes from small changes in the earliest moments. By making maps of millions of galaxies, scientists see the same shapes that were made when the universe was new. These shapes have grown bigger as space stretched around them, but the overall pattern remains. There are mysteries still to be understood. One is dark energy. a kind of energy that makes expansion speed up over time. Scientists do not know exactly what dark energy is, but they know it must exist because of what they see in the movement of galaxies and the way the universe's growth is changing. Dark energy is now thought to fill space everywhere. It does not collect in stars or planets. It cannot be seen, but its effects are all around. Another mystery is dark matter. Regular matter, like gas, dust, stars, and planets, is only a small part of the universe. Most of the mass seems to be invisible. Scientists know dark matter is there because of the way galaxies spin and the way gravity bends light from far objects. Dark matter helps build and hold galaxies and clusters together, keeping them whole even as space grows. The constant work of measuring, checking, testing, and retesting is how science works. Teams of scientists share data from many countries. Space telescopes look at light not just in visible colors, but in infrared, ultraviolet radio waves, and X-rays. Every time a new answer is found, it has to agree with everything already known. If it does not, then the question must be asked again, and the search continues. All the facts so far support the same view of the universe. It is all of space, time, matter, and energy. It grows bigger as time goes on. It began in a very small, hot, dense state and became wide, old, and cold. It has no edge, no outside, and no ending point. The universe's behavior is set by simple rules. These rules, like gravity, the ways light moves, the effects of energy and matter, always work the same everywhere. This is what scientists call the cosmological principle. The idea that every place and every direction in space is the same as every other when seen on the largest scale. There may be more to learn. Science is never finished, and every new question gives rise to more. Scientists ask why the universe began, why space can expand, and what might happen in the future as more space appears and galaxies drift away. They think about whether there could be other universes or other forms of space and time, but so far no evidence of anything outside this universe has ever been found. The deep truth is that all things, sun, stars, planets, galaxies, every person, and every atom are parts of a single, growing universe. Everything we can measure, count, or see is inside. Nothing is outside, and there is no place beyond the reach of laws like gravity and the stretching of space. The expansion of the universe also explains why there is a limit to what we can see. Light travels only so fast, and the universe has only existed for a certain amount of time. This means there is a horizon, the edge of the observable universe. But this is not a border of the real universe, just a limit on how far light has been able to reach us so far. As the universe grows, some distant places will move beyond this horizon, and we will never get any new light from them again. The same will happen for any observer anywhere in the universe. With enough time, each group of galaxies will see an emptier sky. All objects that exist now or will ever exist are part of the universe, carried along as space stretches bigger. No matter how long time goes on, there will never be an edge to find, no wall to reach, and no outside to escape to. This understanding changes how we see everything. We know that we live in a big connected cosmos, where the rules of nature apply everywhere. Our own place, the Earth moving around the Sun inside one galaxy among billions, is just a small part of a universe always growing and changing. The ways the universe expands, the patterns we find in galaxies, and the evidence from old light all fit together. Science asks questions, builds tools, makes measurements, and checks its results. When all the pieces are put together, the story is clear. The universe expands by making more space inside itself. Expansion is not a thing happening to the universe from outside, but the way new space is created within. This is not only an idea found in math or books, but a conclusion proven by all the things we can see and measure. The light from the most distant galaxy, the quiet glow of ancient microwaves, the movement of clusters, and the patterns in the sky all say the same thing. The universe becomes larger, with more space between its biggest parts, even while smaller bodies stay close due to stronger forces like gravity. All the facts that scientists know support the idea that space and time started with the universe, that the universe is always inside itself, and that the distances within it can become larger and larger. Everything, from the most distant star to the closest atom in your body, exists inside the universe and is connected by the same space and the same time. The universe does not expand by moving into nothingness. There is no box, shell, or room holding all space. Every moment is inside, every place is inside, and all growing takes place within the universe itself. As science goes forward, there will still be new things to learn. Each discovery will help make the picture of the universe more clear and more simple. With every experiment, every measurement, every improvement in technology, scientists build new ways to see farther, measure more exactly, and understand better. But the foundation of knowledge is strong. The universe is everything. Its expansion is a real, measured, observed fact. Space increases between galaxies, and this increase matches all that we know from observing light, gravity, and patterns big and small. There are no borders, no walls, and no outside. Only the universe, with its growing space, its connected galaxies, and its long history from the first hot, dense moments to today's cold, wide, distant sky. Each of us lives every day as a part of this big story. The sun, earth, and all the stars seen at night are carried along in the flow of time, shaped by the growth of space. Science continues to learn more, but the great truth remains clear. The universe expands by making more space, not by crossing borders or filling empty places. Everything that is, every moment, and every object is within this universe, connected through the stretch of space and the flow of time. With every observation and every new look into the sky, we find more proof of these ideas. The growth never ends and never needs to end. The universe is simply all there is, all there has been, and all there ever will be, forever growing and forever carrying us forward in space and time.